Greetings of this session. In this session, we will concentrate on calculation of network parameter using mesh current analysis as well as node voltage analysis. This is the second session on this. So let us consider this problem. So here, find the network V0 using node voltage analysis. So this is the voltage V0 which is to be calculated. So using node voltage analysis. So according to the concept, what is the first step? We need to identify the nodes or the points where 3 or more elements connected. So this is the one point, this is the another point, and this is the third point. Along with this is the common fourth point. So these are the 4 points are considered as nodes. So in the next step, assume node voltages except the reference. So that means out of these 4 nodes, you have to consider one node as a reference. Let us assume this node as a reference node. That is means with 0 potential, 0 volt. Now out of these 3 nodes, I will assume this as a node A and the potential at this point as VA. This is the node B and assuming potential at this point as VB. This is the node C with potential at this node as VC. So assume all the node voltages. Now before applying KCL, we should check whether is there any ideal voltage source connected between the two nodes. Yes, in this particular network, so this 12 volt ideal voltage source is connected between A and B, VA and VB. So this VA and VB together now acts as a supernode. This is called as a supernode. Now in this supernode, so to solve the network parameters, 3 nodes are there, so we need to get 3 node equation. One equation you will get by applying KCL to VC, but other 2 equation I cannot apply KCL to this VA because this ideal voltage source is connected or it is a supernode. So in such a case, how to write the equation? Now see here, in this voltage source 12 volt, positive side is connected to VB and the lower potential negative side is connected to VA. That means this 12 volt is applicable to between VB and VA such a way that VB is a higher potential and VA is a lower potential. So I can write the equation as VB minus VA equal to 12 volt. So this I will consider as equation 1. Now apply KCL to this supernode. So apply KCL to this supernode. So which are the elements connected to this supernode? This 1 kilo ohm resistance, this 1 kilo ohm resistance, this is also 1 kilo ohm. So total 4 elements are connected to this supernode. So in these 4 elements, I need to find current by applying KCL. So next step is apply KCL to supernode. So what is the current through this 1 kilo ohm resistance? It is VB minus 0, ground potential. So VB by 1K. So this VB by 1K flows out of the node VB. So this is VB by 1K. Current through this VB is flowing out of the node VB. So as it is flowing out of the VB, this is the minus VB by 1K. Now what is the current through this 1 kilo ohm? This is VA by 1K. So it is also flowing out of this supernode. So outgoing current I will consider as a minus. So minus VA by 1K. Now coming to this 1 kilo ohm. So I am assuming the direction like this. So the current flowing in this direction is VA minus VC by 1K. As this current is flowing out of this node, flowing out of the nodes, incoming current as positive, here it is the outgoing current. So once again minus VA minus VC by 1K. So last part, this, what is the current flowing through this element 1 kilo ohm connected between VB and VC. Here also I will consider the direction is outgoing from the supernode, and the current value is VB minus VC by 1 kilo ohm, as it is leaving from the supernode. So it is once again minus sign, VB minus VC by 1K. So these are sum of all the current equal to 0 according to the KCL. So now to this supernode, these four elements are connected. So in the equation there must be four terms. So these are the four terms. So all are the current through the passive elements. So I will multiply this with minus sign. After multiplying with the minus sign, this one, and by taking a LCM as 1K and then cross multiplying, so what will remain? VB plus VA plus VA minus VC plus VB minus VC equal to 0. So which I will write 2VA plus 2VB minus 2VC equal to 0. So this is the equation 2. So 2 equation we got. Now the third one, that is by applying KCL to node VC. So when I am applying KCL, what are the elements connected to KCL? One is this current source 2 milliamps, and another one 1 kilo ohm, which is connected between VC and VB, and this 1 kilo ohm which is connected between VC and VA. So now here this 1 kilo ohm, when I am considering the equation for supernode, I assume the current direction is from supernode to VC. Now I am writing the equation for VC, so I will assume the direction is from VC to VA. So as reason is because this VC I am considering as a having higher potential. So the current through this VC through 1 kilo ohm is minus VC minus VA by 1K, because it is the outgoing current. Through 1 kilo ohm connected between VC and VB, it is minus VC minus VB divided by 1K. This is also outgoing with respect to VC. Now this source current 2 milliamps, it is incoming to the node VC. So incoming is plus 2 into 10 to the power minus 3 equal to 0. Now this is the current through the passive elements. Taking to the other side of the equation, what I will get? VC minus VA by 1K minus plus VC minus VB divided by 1K equal to 2 into 10 to the power minus 3. So now 1K is a common, so by cross multiplication I will get minus VA minus VB plus 2VC equal to 2. This is the third equation. So first equation, VA minus VB minus VA equal to 12 volts. Equation 2, 2VA plus 2VB plus 2VC equal to 0. Third equation, minus VA minus VB plus 2VC equal to 2. So this I can put it in a matrix form, that is minus 1, 1, 0, 2, 2, minus 2, and this is minus 1, minus 1 and 2 into VA, VB, VC equal to, what are the values? Right side coefficient 12, 0 and 2. So if I solve this equation matrix form using Cramer's rule, I'll get VA as minus 5 volt, VB as 7 volt and VC as 2 volt. If I solve this, I'll get VA is equal to minus 5 volt, VB is equal to 7 volt and VC equal to minus 2 volt. Okay, so if I apply this to this, all equations satisfy. Now in the question it is asked find V naught. So this V naught is same as VC. So V naught equal to VC equal to 2 volt. Okay, so like this. So first assume the node voltages to all the nodes except reference node. Then apply KCL and obtain the node equations. Solve using Cramer's rule. And using the node voltages, calculate the required parameter. So in this case it is V naught. Let us see next. Find mesh currents. So here the network is drawn and they have given the mesh currents also, I1, I2, I3 and resistance value, all this are given. Now I will consider this as a point A, B, C and a point D. Now mesh 1 is A, B, D, A, mesh 2 is B, C, D, B, mesh 3 is A, B, C, A. Anyway, I can consider. So now, while applying a mesh current, first we need to check for is there any ideal current source present in the network. So in this case, this 1 amps is the ideal current source present in the between B and D. So in such a case, we need to go for super mesh. What is a super mesh? Super mesh is a mesh obtained by combining two meshes which contains this common current source and eliminating this element. So this super mesh becomes A, B, C, D, A. So this is the super mesh. This is the obtained super mesh is obtained by combining mesh 1 as well as mesh 2, also by eliminating the common current source element. Okay. Now how to write the equation? So first equation is comparing the source current in terms of the mesh current. So this 1 amps current source is flowing from D to B. So which current expression flows from D to B? I2 minus I1. I2 is flowing D to B, I1 is B to D, so opposite. So first equation is I2 minus I1 equal to 1. This is the equation 1. Now, next apply KVL to super mesh. So, next equation is obtained by applying KVL to super mesh. So what happens to the super mesh? A to B. A to B I am tracing. What is the current flowing from A to B? I1 minus I3. So I1 minus I3 flows from A to B. So potential is minus 2 into I1 minus I3. Now B to C, 1 ohm is connected. What is the current flowing through B to C? I2 minus I3. So minus 1 into I2 minus I3. What is the current flowing through this 2 ohms? Only I2. So it is minus 2I2. Because current direction and the path directions are same. Then what about the source voltage connected between D to A? In the path D to A, it is rising. So plus 2 equal to 0. So what is the next step? Changing all the source voltage drops across the passive element to the other side. So 2 I1 minus I3 plus I2 minus I3 plus 2I2 equal to 2. So simplifying, what I will get? 2I1 I2 plus 2I2 plus 3I2 minus 2I3 minus 3I3 equal to 2. So this is the equation 2. Now 3 unknowns are there, I1, I2, I3, but 2 equation we obtained. How to obtain the third one? Third one is by applying KVL to mesh 3. So by applying KVL to mesh ACBA. So what happens to ACBA? A to C current I3 flows. So minus 1 I3. C to B, I3 minus I2 flows in the direction C to B. So minus I3 minus I2 minus I3 minus I2. Then current flowing from B to E, I3 minus I1. So voltage drop is minus 2 into I3 minus I1 equal to 0, because no source voltage is present in the mesh. So if all are the passive element drops, so multiply with the minus sign or taking to the other side, that means plus, plus, plus. So what happens with simplification? Minus 2I1 minus I2 plus 4I3 equal to 0. So this is the third equation. So 3 unknowns, I1, I2, I3, 3 equations, I2 minus I1 equal to 0, I2 minus I1 equal to 1, 2I1 plus 3I2 minus 3I3 equal to 2, minus 2I1 minus I2 plus 4I3 equal to 0. These are the 3 equations. Using Cramer's rule, if I solve, so I will get I1 equal to 1.55 amps, I2 equal to 0.55 amps, and I3 equal to 0.91 amps. Please check this answer by solving the Cramer's rule. So like this, we need to solve the network using mesh analysis or node voltage analysis. So further we will solve more problems in the next session. Thank you.